So let's start, friends, the session. We'll discuss about new things. We'll start with our discussion with Python. We started understanding Python programming and we looked into its capabilities. To highlight, we talk about open source, English-like language, right? And it is general purpose. And it has both object-oriented and functional-oriented capabilities. Right? This way you have a lot of features that we can talk about. Then we looked into the data types. And here we looked at integers. Then we talked about float. Then we talked about complex numbers. Then we talked about character data. And we also have looked into a special type of data, which is Boolean. This is basically true or false. Then we started discussing about operators as the first thing in the coding part after discussing about the theoretical stuff. In operators, we started with assignment operators, which is basically equal to. And then we've also extended this discussion to plus equal to, multiplication equal to, division equal to, etc. But you also need to understand arithmetic operators. Arithmetic operators are basically saying plus, minus, multiplication, division, percentile, double slash. These are, right, few of the arithmetic operators. Then we have logical operators, then we have identity operators. Then we looked at relational or comparison operators. Right, then we also looked at membership operators. So on and so forth. These different operators we try to cover. And yeah, we also looked into something called as bitwise operator, which is basically converting the data into binary formats. This is required when you are basically doing the machine level programming or machine level coding. Identity matrix, right? Membership matrix is in, not in, is, right? Is not. Then we talked about data structures. As part of the data structures, we learned arrays. We learned about arrays. And we understood one-dimensional arrays. And we looked at vectors. Right? We dealt with one-dimensional arrays as vectors. Then we have two-dimensional arrays. And we try to compare them with matrices. I should say matrices, plural, right? Two-dimensional arrays or matrices. And we also have matrix type in Python. And we looked into the operations that we could do here. We talked about insert, append, remove, delete, right? And accessing the data using index. So these are right, few things that we've learned as part of the array operations. Now today we will start with, okay, one more thing before I go. The documentation in Python is available using this command. You say help of array. When you do help of array, you can clearly see that it is helping us with the documentation which is required for us to understand that particular functionality. It gives clear descriptions, right? Detailed descriptions about the particular code, that particular function. Type code, then your initializer, this is what you are going to get. Type code is nothing but the data types that you are passing to your array. This is something that we prefer, integer or signed integer. If you are passing float, then you'll have F. And generally, these are the things that we apply. So this is basically the array types that you're seeing here. And then, yeah, these are all the functions that you can apply for your array. Append, count, extend, index, insert, pop. Somebody was asking, can I do pop? Absolutely, you can see this pop. Then reverse, to file, to list, right? All these things are available. All right. So this is about your functions and documentations for those particular functions. Now let us today start with the important concept of list. As I said, in Python, everything is basically lists, right? Predominantly we use lists. Now when we talk about lists, right, you need to understand what is this particular list all about. Okay, so in Python, a list is basically a sequence of data. List is nothing but a sequence of data. Now this data that you're talking about can be of different data types. Different data types. It's not restricted that you need to have same data type. If you have same data type, then it becomes vector. Right? That is the difference between vector and list, if you remember. List is a sequential arrangement of data which can be of various types. Now, one of the features that you need to look at for Python list is it is mutable. Very, very important. It is mutable. That means once you created a list, you can edit that particular list and update that list, right, in the memory location. In short, once you created a list object with some value, this value can be altered. You can change the value. Okay? Now, Python has various types of, I should say data types. This is one of the data type, which is popularly used. But Python also has different data types. Okay, we will list out those things. We will try and look into them. We will have, I should say, lists to start with. Then we have tuples. Then we have something called as sets. Then we have something called as dictionaries. Okay, predominantly, of course, we will also have something called as strings. Okay, so these are the different data types that we have in Python. Okay. Now, I should also say anything that I'm forgetting. Set I've written, right? Okay, in set we also have something called as frozen set. We'll discuss that when we actually go to that particular concept, okay? For now, we will only talk about lists. We'll limit our discussion only till lists. So, okay, again, somebody is scaring us. Yeah, be careful, guys, with your cameras. If you still want to share, yeah, most welcome. But make sure your attire is proper, okay? I know we are working from home, so we are in our comfort zone. So I'm at least in my comfort zone, so I don't switch on my cameras generally. Yeah. So again, list is a mutable data type, which basically means the data object or the value can be altered. Okay. And this is sequential arrangement. Lists are sequential arrangement that we see. They are indexed. Lists are indexed, sequential, right? So you have indexed, you have mutable property, and you also have duplications allowed. That means you can have same value repeated multiple times. Okay, so this is basically your list properties. And as I said, it is indexed or ordered. Okay, and different data types can also be available. Now, one very important difference that you have to by heart is in Python that when you are representing a data as a list type, you would define that using square brackets. Remember this. Square brackets would be there. For different data types, you will have different things. We will learn that. But for list, remember it is square brackets. All right. So let us try and deal with lists. So I'm going to type few lists here. You can either execute this. People who already have the code, people who want to execute this, you can simply execute this particular cell wherein it is defining a list called list 1, and I'm representing the data in square brackets. The character data would always be in quotes. And you can also have numbers. You can also have float data. So here I'm going to start. Oops. I'm going to start with data types. And the first one we are dealing with is lists. Okay. So as part of the lists here, let's say I'm going to say L1 is equal to. Remember, we have to put square brackets. I'm putting that. And let's write something here, okay? So today's date is 2020, right? And time is 20. Oh, all 20, right? Yeah, very good. 20 hours. I am teaching, I basically means Sharath is training the participants on Python. All right. So let's take the time as 2020. Okay, 8:20. All right. So 20th August 2020 is a year. 2020 is a time. This is me training Python. So this is a Python list. Now, why I'm typing all this? I want to basically tell you that this is a list that I'm generating. We have square brackets, and I have integers, I have float data, I have character data. And even in the character data, you can see I'm representing single quotes, and I'm also representing double quotes. Python does not differentiate between single quote and double quote. Both of them are strings only. Now, if you want to see this, right, let's remove all of this and let me execute it again. And you see, it is a list. I will say L1, and you can see that it is printing the list, right? Okay, let me see. Okay, is my voice clear to everyone? Again, I'm looking for majority. Please confirm. Okay, I think most of you are. For few people, it is not clear. Sometimes echo. Not sure why is it that. Dolby. Okay. So at times it is echoing. I'm not sure about echo, guys. I have no idea about it. I can try and shift my, I should say, headphones. But yeah, majority of you people have no issues. So let me continue. Probably in break, I will shift that. Okay, so this is about list, friends. We have created a list. All right. Next. As I said, lists are basically ordered. I mean, the list data that you are defining is ordered. It has an index to it. And that index starts from 0. And you're familiar with this, right? We have already seen this in arrays also. 0, 1, 2, 3, 4. That's the index, starts from 0. Right? And you can access the value using this index, just like how we did for arrays. And this data type is basically called as mutable data type. That means the value can be changed. We have seen this capability in arrays also. Remember, we altered a data, right? We basically changed the data using array function. You basically said A1 index equal to a new value. So the value which is at that particular position was replaced with new value. This is called as mutability. You can change a value in the object once it is assigned. If you are not able to change that, then it is called as immutable. Okay? Now, let us look into the few of the capabilities of the Python list. So I will run through a few of the codes that we have here. Right? Before that, let us try and access the content. So first thing we are trying to do is accessing the list objects. So you want to access the float data, the value which is in third position. So what I do? How do I access that? I would say list of, in the square bracket, you put, what is the value that I want to see? This value, 20.20. And this is in the position 2. So here in the square bracket, you have to mention 2. This would give us that value. Now I want to see multiple values, not just one value. I want to basically look at multiple values. So in order to access multiple values, we need to give the value using, give the index values using colon symbol. Right? So if this is represented, this is representing the index L1, this is index, right? We till now have seen just representing one value. But if you want to see multiple values, you can also do that. For example, you say L1, lower limit, colon, upper limit. So you're going to give range of values. Colon basically means sequential arrangement of the data. For index, we can do this. So for example, if I say L1, right, 1:3, what would I get? Let's see who will answer. Ravikan, come on. Yeah, I'm not answer that. 2020, 20.2, and sure. Okay. Pratibha Basu, Nathan, no wrong. Pradeep, Pai Kumar, no wrong. Omkar, 1 to 3. When do we have 1 to 3? No. 1, 2, and 3. Now. Oh, you're talking about index positions. Okay, 0 to 4, no. Okay, so let me talk about this. Very important focus, guys. Few people have got it correct. I'm saying L1 of 1:3. Okay, so I'll write the index here. Index is 0, 1, 2, 3, 4. Now we want the values which are spanning from 1 till 3. Okay. Now in Python, always remember, I'm saying always remember, stressing this point, you have to by heart this, remember this, internalize this. In Python, when you are talking about a range of values that you want to represent, then Python will always start with lower limit. Start. And always ends at n-1. It does not end at nth value, but the upper limit is always at n-1. Always remember this. So you are going to represent lower limit, comma, upper limit. Okay. So what is it doing? It is printing from lower, but it will print till upper -1. Till here only, it doesn't take upper value. Not take this. This is something you have to by heart. And this is one of the features or one of the standards that Python follows. So when I say 1:3, it starts from 1 and sequentially goes till n-1, that is 2 only. Right? So what are the values which are at on those index 1 and 2? It is 2020 and 20.2 or 20.20. Is this point clear, friends? It has to be nailed down into your brains. Is this clear? Very, very important. Don't get confused with this point. All right. So let me print, let me type that. I'll say L1 of 1:3. When I do this, it prints 2020 and 20.2. Now, I would do something like this. I want you people to tell me. Okay, let me say L1 here, :4. Now what will I get? Very good. Very good, very good. So the index always starts from 0. So when you are representing this, if you are not specifying any value, then by default it assumes 0. Right? So 0, 1, 2, and -1. So 0, 1, 2, 3. Right? So these are the values that it prints. So let us see that. All right. Next, another very interesting thing. Let's see who all the logs are. L1, I will say 1:. Yeah. Now what would I get? Exactly, very good. Not everything. I'm starting at index 1. So 20 will not be considered. Okay, index 0 is not considered. but everything from there on is printed. You're not specifying upper limit here. In the index, we are not specifying the upper limit. That means consider everything. Whatever the data that you have, consider everything. That's the logic. All right, so this is about accessing the data using indexes. Right, so that's about the code. Let me see if I have anything else to add on. So yeah, accessing the lists, then we have the representation, okay. And then, okay, append function. We'll talk about append function now. Then we'll also talk about pop. All right. Right, so we are trying here with, let's say, appending a value. Okay, so if I try and append a value, what would I get? How do I append? Append basically is a simple function, and what does append do? Append will basically add a value at the end. Add the value at the end. Okay. I have a question, is there? Cherian, I would request you to try that. See, experiment. You execute that. You will come to know. How rule in case of Rakesh, there is no upper limit, right? So you're basically saying infinity. N minus 1. Infinity minus 1 is infinity. Whatever the data you have, it will get printed there. Simple logic, right? Yeah. So we are basically doing appending a value at the last. The syntax basically is L1.append. Your list.append. You can see that when you're trying to type in Spider, I love Spider because of all these features. It gives us these prompts. Of course, in Jupyter also it will help. In Jupyter, I think it will do that. Let me see whether it does. List1 dot. Yeah, so it doesn't do that. Yeah, Jupyter. That's the reason I'm not too comfortable with Jupyter. I hate it. So list.append. L1 is my list, and I'm doing append. So when I type it, it prompts me, and it also gives me the sticky note. Right? And then if I type that tab button, it will auto fill. And yeah, here, let's say I want to add a data object. I want to add an object. Let's say I'm going to add, saying that, okay, let me add the month, August. So L1.append, I'm passing a value called August to this particular data. If I execute this, then your L1 gets appended with that value. By default, append basically goes and takes the last position. Okay. Now there is a concept called as pop. This is to append. And there is something called as pop. We'll discuss pop first before I talk about insert. We have seen a remove function, right? But we also have a function called as pop. Now the difference in remove and pop is similar to the difference that we have in append and insert. Append will always stick at the end. Insert can be basically at the between, any value in between. Same thing, pop and remove. Pop will always target the last value, Remove can be done from removal of the value from any position. And Python always follows first in, last out. Or you can say last in, first out. This concept. So if you see the list that we have generated here, first you are passing 20, then you are passing 20, 20, then passing 20.2, then you have the objects, and finally you are adding August. This is the last value that added, last in. So when you want to remove, right, pop is basically a removal. So it just removes, it doesn't look at anything. It tries to remove one value, pop out. So by default, it will target the last one. I mean, the most recent one. So it basically is loading like this. So 20 goes and sits here. Then 2020. Then 20.2. Then you have shell. Then you have Python. Then you have August. When you want to pop out, you will pop the first one out, right? Yeah, like stack and queue. Stacking, basically, we are talking about a stack. So it is a stack with last in, first out, or first in, last out concept. Pop basically is removing the most recently added object. So the syntax of pop is very simple. Just like append, you have pop. So you say L1 dot pop. So you say pop, right? You put that. Now, this would go and remove the most recent value. Now, if you see L1, you will not have the August. No, but will pop always remove the last object? Can I not remove any value from in between? You can. So Python gives that flexibility. If I use the same function, the pop function, I'm not going to remove function, I'm using pop function. But in pop function, I'm going to represent the index here. So let's say I want to remove the first value, which is 20. So I'm simply putting the index, right? The first object which went into the stack, I want to remove that. You can absolutely do that. So it is removing the first value, 20. Right? So this is pop function for us. Okay? Next. We are trying to look at, let's say we did append, right? Let's try and do insert function now. Okay? Now I want you people to try out with I should say, remove function. Okay, what are the various functionalities that are available in list for list? We have done pop. You try to do with remove. Experiment with remove. What will happen if I use remove function, right? So just try. First of all, you check whether remove is there or not. Okay. Now, we are going to look at the next thing, which is insert. So we looked at append. Now let us look at insert. Okay. Insert is very similar to what you have done in pop. In append. But append is going to add the value at the end, at the last. right? Always. You cannot pass a index to append and say you add a value at the between. If you want to add a value in between, then you have to use this insert function. So I'll say L1 dot insert. And you can see index and object, that's the syntax. If I press tab, it is going to give that. Then index basically is, let's say I will put a value 2. Randomly I'm putting a value 2. And I want to add an object here. You say, I want a break. We'll execute this. So this break is a keyword, the word. That word is going and sitting in index 2. So 0, 1. Here it will get that break value added. Right? So let us see N1. We have already done pop right here. So 20 is gone. Don't try to look at exactly from this. We have already done pop. So your L1 initially was from here till here. And you are putting a value in index 2. So that is this position. One. That's L1 for us. I mean, insert for us. Now, there is one interesting function or difference that you need to observe, and that is, do we miss anything? Let me cross check. So I have append, okay, I have pop, popping using index, and then we talked about insert, okay, extend, right? Yeah, next is extend. So let's talk about extend now. This is interesting. So when you say extend, it is like, I should say append only with a small difference. Okay. I want you people to understand that difference. So let's say L1, I already have L1 defined, right? This is my L1. Let me define L2 here. Let's say 1, 2, 3, then put in. Okay, I'm adding integers and as well as string. So this is my L2. All right. Now, I will show both append and extend together. So what happens if I say L1 append and in append I am putting L2? What would happen if I do this? What will I get when I do this append function? We have seen append right here. It's basically appending the last, an object into the last position. Okay. So this is adding objects of L2 to L1. So your L1 will get updated. Okay. So this is your L1. Let me show you. So 20.2 break Sharath Python and L2 will get updated here. Okay. Now we will see the difference with extend. Okay, let's do extend. And I'm doing extend of L2. Observe the difference here with extend function. Now if you say L1, okay, what happens? Okay, I think I need to change this. Okay, let me copy this. Okay, so let me type L1 first. This is L1. Okay. Then when I did append, then your L1 gets updated like this. Okay, this is append function. So I'm redefining L1 and then I'm doing extend. Now when I did extend, look at the difference between append and extend functions. When you did append, right, the append function is treating the L2 object as one object. It's a single object. And this object has to get placed at the end position. Take everything as a single object and put it there. That is your append. But when you talk about extend, then L1 gets updated with each of the element of L2 at the end. It is like append only, but it is taking each value of L2 and then it updates your L1. So it is not treating L2 as a single data object, but rather it is looking inside L2 and then updating. Yeah, so this is L1 append L2. This is L1 extend L2. Clear, everyone? All right, so that is basically your L1 extend functions. You can experiment here. So if you do extend, your L1 or your list gets updated with individual values of L2. Okay, so you can say L1 extend L2 or L2 extend L1. Either way, extend works in the same way, it doesn't change. All right, next we have a function called reverse. This reverse function will reverse the positions of the data. Okay, it is going to change, alter the positions of your data points. So here if you see, I have index 0, 1, 2, 3, 4. This is my index, right? This is your L1. Now this L1, I am getting replaced it into reverse, right? Reverse means this will come into index 0, 342. Then ABC will come into index 1. So it will point the index like this, 0, 1, 2, 3, 4. It will reverse the positions. Let us execute this. So 1, 2, 3 is going to the last. 3, 4, 2, which is initially the last position, is coming here. You might want to see that. Print of a list. So if you do this, let me execute this again. So this is the initial value, and then after so I'm just putting separation here. So this is before the reverse, this is after the reverse. Right? So reverse function just reverses the position. Okay? Now we also have something called as a sort function. Okay, we'll look into the sort and then we'll look into the count functions. Post that, we will take the break and come back for tuples. All right. So I'm creating a list and then I have a sort function. Okay, let me execute it here. Reverse function, let me just write that. So I'm defining my L1 and then I'm saying L1 dot reverse, right? L1 dot reverse. I do this, it will print my L1 in reverse order. Now for alphabets, it's taking alphabetical order. Numeric values, it takes normal numerical values. The first letter of your character, right, that would be considered. Uppercase and lowercase, remember that is also something that you need to look at. First preference is for the uppercase letters, then the lowercase letters, then the numbers. All right. Next, we will now talk about sort function. Now sort is very simple. You are basically arranging the values in certain order. Okay, so let's say list is equals to, I'll simply put some random numbers, 12, 6, 37, 1 to 3, okay, 0. This is your list, okay? I'm defining L. Now I'll simply say L dot sort, okay? That's it, I'm not passing it. When I do this, your list will get sorted out. Okay, your list is getting sorted. Now, if you see L, the values are arranged in ascending order by default. When you say reverse is equals to true, that is when the values will get ordered in descending order. So you can pass values like this. Say L dot sort, and in the sort, I'm passing the arguments. I'm saying reverse is equals to Boolean operation, that is true. You should see the color change, okay? When you do this, the data will get arranged in decreasing order. Now you can see it's arranged in decreasing order. Sort, very simple function. We will also see another type of sort, and I'll talk about the difference between these two when we do that. Two different approaches of sorting. But yeah, this sort is basically arranging the data in ascending or descending order. If you have alphabets, it will be taking your alphabetical order for your data, first letter of your alphabet. So if I basically, let's say, do sort on L1. If I do L1 sort and, oh, I have float also, right? It will not do that. It's not able to confirm, identify the difference between float and integers. It will not be able to do that. Okay, what we'll do is, we'll create, do we have L2? What do we have in L2? Yeah, L2, I think it should work. L2, okay, let me just check, okay? I don't remember. It might work. It's not doing. Sort function will not be available on multiple data types. You need to have complete list with the same data types. Only then the ascending descending order works. We do have something called a sorter. We'll look into that. L3 is equals to, I'll say hi Python. Yeah. And then we say 360 digit. I'll also add my name. All right. This is my L3. L3 dot sort. It should work. Yeah. So now if you say L3 here, you get this. So it is ordering the data on alphabetical first letter of your alphabet. Of course, 360 digit MG. 360 is a number, so first it gets that value. If you say decreasing order, or order, you say reverse is equals to true, then it is going to reverse is equals to true, and execute this. Then it will basically do the reverse order printing. Yeah. All right, so that's basically your list. These are a few of the operations that we are doing on list. There are various other things that we can do. So we did sort function, and okay, count function is there. Let me look into the count function also. Count basically is giving the number of iterations, number of repetitions. Okay, it doesn't count the objects, or it doesn't do the length of the object. For doing that length, we have length function. So here, let's say I will do one thing. I will append L1 with L3. Okay, L1 dot append L3. Now when I do this, my L1 will become, oh my bad, I should have done extend, my bad. So let me do one thing. Let me talk. Okay. So I do L1 extend L3, and if I say L1, okay, these are my values. Now on this, I want to do a count function. Now this count, right, very interesting, will help us see how many times the value is repeated. L1 count, and what is the object that we want to check? Let's say I want to check for the word share, mine. Okay, when I do this, it will see how many times the word is repeated. 2 times it is repeated, so I should get a result as 2. Yes, look at that. So it is counting how many times the value is repeated. So this is basically your count function. All right, now let's take questions, and then we will take a break. Can we write a user-defined function to reverse? That would be a hectic job. Why you want to do that, Kumar? You already have predefined functions, right? I would not waste my time. I'm not a programmer. I have ready-made function. I use that. When I'm executing L1 dot extend L2, I am getting an error like this. Integer object is not. You might have defined L1. Integer object is not iterable. If you're just type error. Okay, probably you have not typed it list format properly. You need to cross check that once. Did you give the square brackets and all that? Just check from that perspective. String indices must be integers. You're getting type error.
Yeah, these are basically because you might have right, by mistake type something there when you're defining the list. It is there, Mangalam. The Jupyter notebooks are already there. That's what I was saying, right? Don't you have the access to elements? Frequency. Yeah, appending and concatenating are same. Appending and concat are same. I think so. I don't remember. I need to check what is it. When I do concat, what would I get? Concat, concat, concat. Probably not. Concat is like extend if I'm not mistaken. We'll see. Shrillata will see. Is the study maybe supposed to have program is it has some other place? No, it should have the Python notebooks. With that, I'll get the code, and if I open this, it has folder, and it has 3 IPython notebooks. I'm using this module 1.ipynd. Open this in Jupyter Notebook, you'll be able to see the same codes that I'm running. In module 1. Voice is very low, voice is very low. Can we check the backend effect of all these steps? What do you mean by backend steps? Okay, we'll go for a break, and post the break, right in between, I'll try to change my audio settings, and we'll see. Probably it should connect now, probably. So we'll take, as usual, 8 minutes break. We'll connect at 9:20.
All right, guys. Yeah. All right. So let's talk about the tuples now. But yeah, did we do remove option? I think we did not do remove, right? Let me just okay. So let me just show you how do we do remove in Python. We have not done remove, right? So let us do that. We did talk about pop function, and I wanted you people to do remove, but let me just show you the remove function as well. Let me type in here itself. All right. So removing basically is very simple. L1 dot remove. Why is it not coming? Ah, yeah, remove. And then yeah, in L1 I want to remove the object which is in the, let's say, first position. So if I see L1 first, it is 0, 1. So I'll be removing my name from this particular list. So pop and remove. But these are, how come? X is not in list. Why is it not saying that? Okay, my bad. X is not in the list. X is not in the list. So 2 is not there in the list. Okay, my bad. So let's say I think I have, okay, 20.2. Let me type that. All right, so we are not using index basically in remove. My bad. I want to remove the object which is basically 20.2. Right, so remove would basically remove the value that you are specifying. Okay, just got confused. All right, so pop basically is index, remove is the value itself. So if I say remove, right, I put Sharad, then it is going to remove the first value that it encounters. Only it removes one iteration. It doesn't remove multiple repetitions. Okay, what is the first value it encounters? Only that value is removed. So initially it had a value called Sharat, right? So it is removing that, but it is still there. The other Sharat is still there. If I execute it again, now it will remove that second repetition as well, right? So yeah, that's one of the differences with your remove function. If you want to basically repeat, I mean, remove all the values at single go, then you have to represent the number of times that you want to remove that particular value. Again, how do I find that syntax? I would do this remove, and if I click here, you get this pop-up, right? It's not staying there. Yeah. So you can see this is the object. It's not showing much details. My bad. Okay, fine. You guys explore. I don't want to waste time on that. Just try and search how you can remove multiple iterations. There will be a parameter that you should be using. Try and do that, and it would basically remove all the values right? Or you can also set specific number of values to be removed. That also you can experiment. All right, that's about the remove function in lists. But let us move on and talk about the tuples, guys. Tuples is important, so we'll end here. We have understood the fair bit of concept of lists. So let's now talk about tuples. Close this. Tuples are very similar to your lists. Okay, when you say tuples, they are very similar to your lists. Okay, but there are small differences. Remember, as when I started discussing about lists, I said that list is one of the data type that Python has, but it is having certain features. It is sequential ordered data. So that means it is sequentially ordered data. It has index. It is allowing duplication. It allows duplicates. And the most important thing is it is mutable. We can alter the values. But when you talk about tuples, tuple is another data types in your Python. Okay, this is one of the data types in Python, which is a sequential data. I mean, it is sequentially ordered data. Okay, it has index. It will allow duplication. But one primary difference is it is immutable. That means once you define a tuple, you cannot alter that tuple. You cannot change the value. And when you are defining list, you use square brackets. And when you're working with tuples, you use your regular brackets, the cup brackets. Okay, and there's just like your rest of the things are just like your list only, comma separated values, right? Those things will be there. But here you are representing your regular brackets, remember that. All right, now let's deal with, right, tuples here. I'm spending a lot of time in these things because these are the foundations for your programming. Okay, everything that you do in programming is revolving around these data types only. If you are familiar with data types, if you understand these features, then writing codes will become that much simpler. Okay, so focus, practice on these foundational concepts. Okay, tuple, as I said, is represented using your regular cup brackets. Okay, so I'm going to try and assign the same values that we have assigned for list. I'm basically saying 20, 2020, and right now it is 21 comma 3 930, and then I'll say Sherrod, and then I'll say Python. Just the values are changing. So this is your tuple. Okay, now here I forgot to talk about the data type. In Spider, you have this environment variable explorer, which would show your variables that you are defining. Okay, in Jupyter, as I said, I don't have an option to look at those things. Of course, you can say ls and then get the list. If I'm not mistaken, ls will give you the list of the objects. Now, I'm familiar with R, so I get confused with these two, but I think ls should work. Okay, so if you want to understand the data type, then there is a function called type. Okay, let me just show you this. You say type of a list. Okay, let me execute this first so that I define a list, and type of you say, it says the data type is list. Similarly, here you are defining tuple, right? You are putting your regular brackets, and if you say type of your tuple, I mean type of the tup1 that you have created, or tup2, it will show that it is a tuple data. Yep. So this is basically your tuple, and it shows tuple. You can simply say type. Here also you can type the same thing, t1. It's basically giving you this data type, tuple. All right. Next, there are certain operations that we cannot do on tuples, certain operations that we can do on tuples. But before that, how do we access the values? Just like how we access the objects, individual values in lists, right? Same way, we access the values of tuples. The index remains same. The value starts from 0. So if you say t1 of, let's say 2, then this is going to give me 21.3, right? Then you can also say t1 starting with 2, and then you put 4. Then it is going to start from 0 till n-1, that is third value, 0, 1, 2, 3, right? So for these 4 objects, 4 values are printed. Similarly, you can say t1 and put 2 comma colon. So it is going to print from third value to all the values, just like your list concepts. All right, so this is basically your tuple access, the objects access into your tuple. All right. So yeah, this is how we access the tuples. Tuple of 0 is street triple. This is your value. Then you're defining tuple with 7 values, and when you say tuple 1 colon 5, it is going to print second, third, fourth, and n-1, these objects, right? So 2, 3, 4, 5 is what it is printing. Then if you want to update the tuples, this is what you do. So what is basically happening here? I'm creating a tuple with values 12 and 34.56. I have 2 tuples basically I'm creating, and then I'm doing tuple 1 is equals to tuple 1 plus tuple 2. Okay, so we'll talk about this. Let me create that. Okay, so we already have t1. Let me talk about t2 now. Some regular tuples I'm just doing 3, 4, 5. Okay, simple tuple 2. I have tuple 1, tuple 2. Now if you want to update a value in tuple 1, you will not be able to do that. Yep, you'll not be able to update tuple 1. For example, if I say t2 of 1 is equal to 50, I want to change this specific value to, let's say, 20. If I do this, it should not work out. Tuple object does not support item assignment. You cannot add a value to your item. If it is a list object, it would have worked. So if I execute the list, I have list, right? L2. This is my list. So I'm changing this object 2 to 20. right? I'm just changing this to 20. So I'll say 1 is equals to L2 of 1 is equals to, let's say 2020. If you see L2, the value is getting changed. That is because list is mutable object, whereas tuple is immutable. Now, once you defined a tuple, you cannot alter this. This will throw error. Okay? You cannot assign. You cannot do that. Now, what we have seen in the code is we are doing T1 equal to T1 plus T2. When I do this, what is happening here? It simply adds the two values. It simply adds the two values. And it is assigning that new object to a variable called T1. Okay. So it is not updating. Oops. My bad. Yeah. It is not updating T1 values, individual items. It is not updating that, but rather it is replacing T1 completely and pointing to a new object. Okay. Updating an individual value of a tuple is not allowed. So this, when I do this, and if you say T1, the T1 will be completely changed. So it is a new object that you are creating. Yeah. It's not like appending or it's not like extending. Those things will not work here. Right? Append is an in place function. Okay, there is something called as in place commands. The sort function is also an in place function. Append is also an in place. Extend is also an in place function. Okay, what does those in place functions? We'll discuss that at a later stage. Don't worry. So these T1 is getting completely changed. It's a new variable altogether now. Right? This is the result of T1. All right. Next, if you want to do, let's say, I should say, if you want to work with append function on your tuple, what would happen if I do that? Let's say I want to do an append function here. Let's say T1 dot append. Let's say 20. Tuple object has no attribute called append. The function itself is not defined for tuple objects. Right? So these things will not work out. There is a function called delete for your lists. You can do that also. But when you try to do delete a function, it will not delete it. Okay? It will not work. You might want to delete some value. Okay? Let's say I want to delete an object which is in, let's say, in the first position. Invalid syntax, is it? I think delete space T1. Yeah, this is the valid syntax. Doesn't support item deletion. Individual location values, it will not work out. But you can completely remove a value. So for example, I want to delete T2 completely. You have T2 here, tuple. You cannot append or you cannot extend anything. See, remember one thing. Immutability basically means Once a tuple is defined, you cannot change it. This object that you defined as a tuple, sorry, the regular brackets. See what is happening basically, it is, let's say, a memory location. Okay, this is your memory. Using Python, you're saying I'm storing a tuple, right? And you're referring this using a object t2. It's a variable name. You're pointing to that. Now, you cannot alter the values which are assigned here already. That is something that you need to understand. You can either delete completely or create something. Now, when you're creating, you're going to create a new value and say t2. You're not altering this, but you're creating something new. Altering, updating is not allowed. Okay? If you want to delete any one value, it is not allowed. But if you want to delete the complete tuple, yes, it's absolutely possible. T2 is deleted, you can see here. Right? So these are tuple functions. Okay? Tuples, as I said, will not have any operations which are updating the value. Okay, what you have seen here is concatenation, friends. Somebody was talking about concatenation, right? This is nothing but concatenation, and it is like extend. It's not like append. It's like extend. And remember, tuples are also sequential values. It is indexed, right? It is indexed. It is sequential values. Okay. So when you have a constant value, let's say something which should not be altered, right? When you have a constant value, then tuples are preferred. Yeah. That's something that you need to look at. So if I try to quickly explain the differences between tuples and your lists, let me try and list them down here. Well, very important because most of the times we use these two only. Okay, so let me try and list the differences out. The first and foremost difference is, okay, let me write list here. Let me write tuple here. The first and foremost is, this is mutable. You can alter. This is immutable. The another very much noted difference is the square brackets and regular brackets. Right? Now, once your object is defined, you cannot alter it. Okay? That's your immutability. Whereas here you can alter it. When you look into the comparisons, both of them are sequential values. They have indexed values. Okay? Both of them can allow duplication. This is similarity. Okay? And any alterations to your list are entertained, but any alterations to the objects of your tuples are not entertained. Okay, that's the difference between lists and tuples. All right, so I think that's about your lists and tuples. Let's see a few questions have been. Tuple is a fixed value set till the program. Yes, it is fixed. You cannot change that. Yeah. Yeah, try out, Anuj. That's what I'm saying. Please experiment. How can we identify suddenly looking into a variable whether it is a matrix or list, since both are in the square brackets? Dimension, Sundar. Delete T2 is not removing T1 from. Why will it remove T2 from T1? It will remove T2 only. It will not remove specific objects. Yeah, you have to check, Sundar. When you're writing the code, you need to know what you're writing. You need to cross check that. Yes. What's the last word? Duplicate. Yeah. I'm a doctor. Yeah. You have to become a pharmacist to understand my handwriting. Duplication. Duplication basically means in a list you say 1 comma 2 comma 1 comma 2 comma 3, right? This way you see the duplicate values are allowed. Here also you can have 1 comma 2 comma 1 comma 3 comma like this. These duplications are valid. It allows that duplication. Okay. All right. So this is the primary differences between tuples and lists, friends. All right. We do have right the couple of changes that few things that we need to look at, and one thing that we would look at now is sets. Okay, next is sets. Let me cross check in the code if I missed anything. Concatenation tuple is there. Oh, okay. Yeah, pretty much those things that we need to discuss about tuples. We have added T1 and T2. Of course, that is a new tuple, Ajit. It's completely new tuple now. You're not getting, Ajit. You're not getting this. You have T1, you have T2. Now tuple is immutable. What does immutable means? You cannot alter the values that are already defined. Okay. So when you do T1 is equals to T1 plus T2, this T1 is forgotten and T1 will become a new object now. It's a single object. It has nothing to do with this T1. It is a new object, and in that new object, when you're creating, you're adding the content of both T1 and T2. Now when you delete T2, it will delete this object, not the values inside this. It is immutable. You cannot alter the values of T1. Right. Single dimension array same as tuple, third, sorry, same as list, sir. Those are different data types. These are different data types. Sundar. Arrays have different features. Lists have different features. Tuples have different features. Yes, they are one-dimensional. Yes. Count function works on tuple, right? Count function, yeah, it should work. Yes, it is indexed. It should work. Single dimensional array same as list. Yeah, it is. Yeah. So tuple nesting. Tuple nesting, I didn't understand. Oh, you're talking about nested tuple? Nested tuple. Never explore. I don't remember, Kumar. We can try that. I'll just try that now. These are a few things that unnecessary, unless until we specifically check, we don't remember. So let's say T3 is equals to, I'll say 1 comma 2 comma 3 comma 4, and here can I put a tuple inside a tuple? Let's see. 1 comma 2 comma 3. Not sure if this is valid. Yeah. Whatever I typed is gone. Okay, let me type it again. T3 is equal to 1 comma 2 comma 3 comma 4, 1 comma 2 comma 3. Let's see. Yeah. So yeah, that's working. T3 is a nested tuple. So yes. All right. Kusum, we have already done concatenation. Refer back. T1 plus T2 is nothing but concatenation. when we define a list using list constructor, can we give the size of the list as an input variable, list iterable? What should be given for iterable is basically the iterations, how many times you want to access the list. If the list has only 4 elements, but I give or even try to append using some index which is greater than the size of list, it is not throwing any error because it's not fixed size, right? List does not has any fixed size. Tuple will throw error because for tuple it is fixed alumni. That is one of the differences between list and tuple. When I was trying to differentiate between list and tuple, because it is mutable, the size is not fixed. Size is not fixed. Whereas here, once it is defined, it is fixed. It is immutable, right? You cannot change it. So the values are fixed. You can do iteration for tuples. You try those iteration commands on tuples and you will see that difference. Yep. All right. Array is one dimensional, right? Now we are using list only there, right? In array, so it should not be fixed. Dimension would be fixed, length would not be fixed. How are you going to access them? If you don't have indexes, how are you going to access a specific value? Does complex numbers only take J? No, it has nothing to do. You can also do X as well. I don't think it has any specific thing for complex numbers like that. As far as I remember, nothing like that. No, it should not give any, I mean, it can take any value. It should not be fixed for I. But yeah, most of the programming languages have that fixed values. I literally don't remember. Sorry, I need to cross check that, Kumar. Searching and sorting can be done. It should be fast in tuples. It should be because it has a fixed memory, right? So it's basically should be faster. Okay. All right. So we covered lists and tuples today. Experiment, guys. Please experiment. All the questions that you are asking me, I want you people to experiment rather than just asking me. Okay. It's just a programming. Maximum what you get, an error. That's it, right? So experiment. I'm also human. I cannot remember everything at a single go. Same thing goes with you people also. Whenever you think and whenever you get these questions, list them down, do hands-on and record those things. Okay, record. You might want to also want to take a screenshot. That way you will try to remember things easier. Okay. Ashutosh, yes, whatever the assignments, whatever the topics that we are covering, you have to complete those, right, assignments. There are close to 8 or 9 assignments that we have there, and see what all are relevant. I need to cross check. Tomorrow also we have few things. We will cover sets and dictionaries tomorrow. And we'll see what else we can cover. So we have sets, then we have strings, okay, and then dictionaries. So probably we should be able to cover till dictionaries, and then yeah, conditional statements would come in. All right. Let's see. Let's discuss on the assignments tomorrow. Yes, Sundar, that's correct. Sort is in place function. Is it applicable for tuples? Oh yeah, try out. It will not work out. You will see. Logically, think logically, Gitanjali. Okay. You experiment. What is the result you will get? It's a sort function. Just say t1 dot sort. So what do you think? It's an in-place function, right? Should it apply to tuples or not? Gitanjali, what do you think? Yes, it should work. Okay. Experiment. Immutability is a immutability is also something that we need to look at. Check. Can you tell where can we get this notebook lists what we are experimenting? What we are experimenting? Surendra, I didn't understand. These codes, these workbooks, I request you people to try out, create your own notebooks. I would encourage that. In fact, everyone, all the trainers in 360DigiTMG, we want you to do hands-on. But anyways, these codes will be shared. It should be there in LMS, Surendra. Pratiti will discuss about assignments tomorrow. If you want to work on the assignments tonight or tomorrow morning, go through the assignment questions and see whatever is covered. We have covered till what tuples, right? Anything which is relevant to the topic in the assignments, you work on them. Pradeep says, sir, I can work on the spider. I cannot resolve it. That's okay. Why you are working on spider? You can work on Jupyter notebooks. Type the same commands line by line in each cell in Jupyter. This is there, Surinder, already. As I mentioned, it should already be there in the LMS. Are you from the new batch, Surinder? When did you join? If you are a new student, I mean, if you are joining for the new batch, then you should have access to your LMS. You should see something data science underscore study material. You should have this folder access. If you click on this, the first module is Python programming before CRISP DM. Yeah, check that. You should have. Maruti, download that. Just explode, right? I just explained. I've shown you on the screen. Download that content. It has zip file. Unzip it. You get module1.ipynb. This is the zip file that you get. If you open this, extract the files, you see these three files, module 1, module 2, module 3. These are the IPython notebooks, Murthy, sorry. Check in LMS. You should have. If you are a new student, you should have. This is recently added to the new batch, right? So okay, we'll conclude the day, and tomorrow we'll discuss about interesting things again. Sets and dictionaries are two additional data types like your lists and tuples. They have their own capabilities, their own features. We'll talk about those features tomorrow. And the fifth data type is strings. We'll also talk about the strings. So we'll look at strings as well. Okay. All right. Good night for now. Thank you guys. Good night.